Hey everyone, I am Miss Hu, your physics teacher. In this video, we'll be going through energy resources. In this video, we'll be learning about energy resources and how they generate electricity, advantages and disadvantages of the energy resources, as well as renewable versus non-renewable energy resources. Now, there's actually a lot to know about energy resources, far more than what this video lesson would be covering. So please feel free to do your own research. This video is designed for students who are taking the IGCSE Physics syllabus. So what we'll be covering in this video is just the content which students need to know in order to answer their examination papers. So, first things first, we need to understand what renewable and non-renewable energy resources mean. Renewable energy refers to energy sources that can be replenished naturally within a human lifetime. That means that for this energy source, even when we use it, it can still be easily replaced within our lifetime. Non-renewable energy, on the other hand, refers to finite energy sources that cannot be replaced once it's been used up, such as fossil fuels like coal, oil, and natural gas. So once they're finished, they're finished. Even if we want to replace them, it would take an incredibly long time. For example, it could take millions of years. Now, let's go through some of the different types of energy sources, starting with fossil fuels. Now, fossil fuels are natural resources that form from the remains of ancient plants and animals, primarily in environments that were once covered by water, such as swamps and oceans. Over millions of years, these organic materials were buried under layers of sediment and subjected to heat and pressure. This process transformed them into coal, oil, also known as petrol, and natural gas. That's why we call these fossil fuels, because these fuels are formed from the fossils of plants and animals. Now, because these are formed from fossils, these are non-renewable energy sources. It takes millions of years in order to form these fossil fuels. Biofuels, on the other hand, are renewable fuels made from organic matter from plants or animals. For example, ethanol, biodiesel, and wood cuttings. So these are renewable because they're made from plants or animals. For example, you could just cut the plants down or take the carcass of dead animals and convert them into biofuels easily. Wave energy is energy that comes from the movement of surface water waves on oceans, seas, and other large bodies of water. This energy is generated by the wind as it blows across the surface of the water, creating waves. Because wave energy comes from the movement of waves caused by wind, this energy source is renewable. Now, for tidal energy, is a renewable energy source that harnesses the kinetic energy of moving water caused by the rise and fall of ocean tides. The difference in tides will cause a turbine to turn. So in a nutshell, the tide is caused by the position of the moon relative to the earth, and that causes the water to move up and down, creating tides. So as the tides rise and fall, we are able to harness the energy of these tides by means of a turbine, because as water flows, it will spin the turbine. Because this is just dependent on the movement of the tides, this is a renewable energy source. Hydroelectric energy is a renewable power source produced by the force of fast-moving water such as rivers or waterfalls. So in order to harness hydroelectric energy, we have to build a dam which stores a lot of water up to a great height, and then when the dam is open, the water will fall out and flow at very high speed. We make use of the speed of the moving water to spin the turbine, generating hydroelectric energy. Because this is dependent on water, this is a renewable energy source. Geothermal energy is energy that originates from the heat stored within the Earth's core, generated by the planet's original formation and the ongoing radioactive decay of matters within the Earth's interior. This heat is then transferred to rocks and fluids underground, which can be tapped to produce energy when accessed through wells. So basically, geothermal energy, coming from the terms geo, which means ground, and thermal, which means heat, The heat energy from the Earth's core is released to the Earth's surface, kind of like a valve in a pressure cooker. We harness that energy in order to generate electricity. Because this energy comes from the Earth's core due to ongoing radioactive decay, this is a renewable energy source. As for nuclear energy is the energy released from the nucleus of an atom. This can be through nuclear fission or nuclear fusion. So currently, the nuclear energy that we can harness is in the form of nuclear fission, which is used to generate electricity in nuclear power plants. If you'd like to know more about nuclear energy, please watch my video on nuclear fission and nuclear fusion. Because nuclear energy depends on the availability of radioactive material, which is finite, nuclear energy is considered to be non-renewable. Solar energy is the energy from the sun's light and heat that can be used to generate electricity, heat water, and much more. So there are two kinds of solar panels that we can use to harness the solar energy. Solar cells convert light from the sun to electrical energy. There's also another type, which is the solar water heating system, which absorbs heat from the sun to heat water. Because solar energy is from the sun, this is a renewable energy source. Wind energy is a renewable energy source that uses wind to generate electricity. Wind turbines convert the kinetic energy of wind into electrical energy. And because this is based on the movement of wind, as it says here, wind energy is a renewable energy source. Now let's learn in general how energy is generated from those different resources. So just going to move my face out of the way here. Now, if we want to be able to generate energy, we would need to use a generator. If you'd like to know more about the construction of a generator, please watch my video on generators. For now, let's just learn in general how to convert the energy from those resources into electrical energy. Usually, in order to be able to harness that energy, we would need to connect a turbine to a generator. The rotation of the turbine will cause the generator to rotate. So inside the generator is where we have the electromagnets and the coil, and that is what will generate electricity. So the reason why we need the turbine is because usually we would need to convert the kinetic energy from those resources into electrical energy. But we cannot apply the kinetic energy directly onto the generator. For example, we can't get the wind to blow the generator to make it rotate. It could spoil the generator. So instead, the kinetic energy is applied to the turbine. The turbine and generator is connected in such a way so that the turbine will cause the generator to spin together. So you can see that there's a shaft here that connects the turbine to the generator. The turbine has all these wicket gates, which is what will catch the movement of the particles, for example, water flow or air particles. So the movement of water or air will cause these wicket gates to spin, causing the turbine to rotate. So as the turbine rotates, the shaft will rotate and the connected generator here will rotate together with the shaft. So that's how the turbine is able to make the generator rotate. So in this case, whenever possible, we will have a direct connection from the energy resource that can rotate the turbine. For example, wind, wave, tidal, as well as hydroelectric. But what about the energy sources that don't have any kinetic energy? Usually, in that case, we would be using the steam engine. So to harness chemical energy from fuels such as fossil fuels and biofuels, the fuel is burnt and the heat is used to boil water. The steam is then channeled to rotate the turbine, which then turns the generator to generate electricity. So that's how we're able to generate energy from resources such as fossil fuels and biofuels. Based on everything that we've learned, you should be aware that the sun acts as the main source for all energy resources except tidal, nuclear, and geothermal. So this is an important thing you need to remember. One easy way to remember this is just remember TNG, or as how some of us would say, touch and go. So T, tidal, and nuclear, G, geothermal. These three do not have their energy source from the sun. For example, tidal depends on the moon. The nuclear energy is taken from the radioactive energy within the atoms, whereas geothermal is from the Earth's core, which is dependent also on the radioactive decay. All the others are dependent on the sun. For example, hydroelectric energy will require the water cycle in order to be able to store water in the dam, and a water cycle relies on the sun through evaporation. Wind is also caused by sun because the sun will heat up the air, and as hot air rises, cold air would then go in to fill in the space, creating a current, which essentially is wind. Wave energy depends on wind, so it depends on the sun. Fossil fuels, which are plants and animals, require the sun in order to live in the first place before they die and form fossil fuels and biofuels. So that's why we consider the sun to be the main source of energy for all the energy resources except these three. Now let's just have a quick overview about all these different energy sources. So this is a table that compares the renewability, availability, reliability, scale, and environmental impact of all these different energy sources. So fossil fuels are non-renewable. They are depleting very quickly. They're highly reliable, meaning that when you have them, it's easy to burn them and extract the energy very quickly. They're highly scalable. Fossil fuels are actually one of the main sources of energy in the world. They provide 80% of the world's energy. However, they do have high emissions and it can cause air and water pollution. Biofuels are renewable. They're easily available, also very reliable, and they're scalable. In terms of the environmental impact, they do cause air and water pollution, also requires a high amount of land use in order to produce the plants and animals for the biofuels. Wave energy is renewable, highly available at seas and lakes, but it does depend on the technology available to harness that energy. They're also highly reliable because there's always going to be water waves, moderate scalability, but unfortunately they do cause disruption to marine life. Tidal energy is also renewable, but it's only available at regions with strong tidal currents. So although there are tides all over the world, in some places the tides are not strong enough to make it worth it to make the tidal energy a viable source of energy. They're highly reliable because there's always going to be tides. They have moderate scalability, but they also can cause disruption to marine life. Hydroelectric energy is renewable, but they're only available in areas with hydroelectric dams. Hydroelectric energy does depend on the weather. For example, it does depend whether there's any rain so that there's enough water in a water catchment for the hydroelectric dam to be able to release to generate the electrical energy. They're highly scalable, but they can cause disruption to natural water flows, fish ecosystems, and can cause displacement of communities. Geothermal energy is renewable, but they're only available at areas with geothermal energy. In those areas, the energy is highly reliable, but they are limited to the cost and technology. The environmental impacts are surface disturbances and can cause chemical contamination of groundwater. Nuclear energy is non-renewable and they're only available at areas with uranium stores. Uranium is the fuel that's used in nuclear power plants. For the nuclear power plants, the energy is highly reliable and it is scalable. The problem, though, is that we have to consider the radioactive waste generation and disposal. Solar energy is renewable and they're generally available in all locations, but it does depend on the amount of sunlight received. Because of this, the reliability depends on the weather, and its scalability is limited to the technology available to harness the solar energy. The environmental impact most widely felt with solar energy is the high amount of land required to build the large-scale solar farms. Wind energy is renewable, but it's only available at areas with high wind currents. So just like with tidal, although there's wind everywhere, in many places the wind is just not strong enough to be able to harness the energy efficiently. So that's why wind energy is best harnessed only in areas where there's very, very high winds. The reliability does depend on the weather in terms of whether there's enough wind, but the scalability is very high. Similar to solar cells, it does require a lot of land use for the wind farms, and in addition, it can also cause noise pollution due to the wind turbines. Now, how the sun generates energy is through nuclear fusion. If you'd like to know more about nuclear fusion, please watch my video about nuclear fusion where we go through the process. For now, you just need to know that there is continuous research being carried out to investigate how energy is released by nuclear fusion and how it can be used to produce electrical energy on a large scale. While we do have nuclear fusion reactors, but they're only in experimental stages and have not yet reached commercial levels of generation. So most of the nuclear energy that's being generated on Earth at the nuclear power plants are through nuclear fission, which is different from nuclear fusion. To know more, watch my video on nuclear energy involving nuclear fission and nuclear fusion. And that is it for this video. So if you found this video to be educational and helpful, please click like and subscribe for more free physics lessons. Do check out my YouTube channel for videos on other lessons which you might find helpful. If you'd like access to notes, quizzes, and syllabus updates, please visit my website at physicsrocks.com. If you'd like to help me keep making free educational video lessons and lab practicals, donations are welcomed at my Ko-fi page at ko-fi.com/physicsrocks. Happy studying!